Hello everyone, welcome to M for Mathematics. In this video, we'll be solving one more question from definite integration. Let's start. So the question is, show that integral 0 to pi by 2 log sin x dx is equals to pi by 2 log 1 over 2. So in this question, we will use this property of definite integration 0 to a fx dx is equals to 0 to a f a minus x dx. So in our case, a is pi by 2. So I'm considering this integral as I, and then we'll apply this property. So when we apply this property, it becomes 0 to pi by 2 log of sine pi by 2 minus x dx. Sine pi by 2 minus x will become cos x. So this is I is equals to integral 0 to pi by 2 log cos x dx. Now I'm saying that this equation is number 1 and this is a number 2, and then we will add 1 and 2, adding 1 and 2. So when we'll add these two equations, this I and I will become 2i on the left hand side. Both the integrals have same limits, so we'll put them in one integration only. So it will become log of sin x plus log of cos x dx. Now here we'll apply this property of log, which says log m plus log n is log m into n. So it becomes 0 to pi by 2 log sin x into cos x. Here we have 2i. So now we'll multiply and divide by 2 inside the bracket so that it will become one trigonometric identity. So I'm multiplying by 2, say 2 sin x cos x, and we'll divide by 2 as well. So it becomes 2 sin x cos x is sin 2x. Now here we'll use log m over n is log m minus log n. So this will be divided into two different integrals. So this we need to do separately. I'm giving it a name, say I1. So first we'll solve this one. Let this 2x as t. So it becomes dt over dx. 2. So from here, our integral will become log sine t. In place of dx, we will have dt by 2. So at this step, when we change the variable from 2x to t, we need to change the limit as well. So when x is equals to 0, we can see that t will be 0. Here we'll put x is equals to 0, so we'll get t is equals to 0. And when x is pi by 2, so t will become 2 into pi by 2, that is pi. So now this I1 becomes half integral 0 to pi log sine t dt. Now after this step, we will use this property of definite integration. It says that 0 to 2a fx dx will become 2 times integral 0 to a fx dx if f of 2a minus x is equals to fx. So we'll apply this property here. So in our case, 2a is pi. This limit 2a is pi. So first we should check that whether our function is verifying this condition or not. So let us see f of pi minus t, that is log sine pi minus t. It becomes log sine t. So it's verifying the property. So it means our integral, this I1, will become now 2 times integral 0 to, so limit pi will become now half of pi, that is pi by 2 log sine t dt. This 2 and 2 will get cancelled. So now I1 becomes integral 0 to pi by 2 log sine t dt. So we know one property which says that if we are just changing the variable, it will not affect the integral. So in place of log sine t, I am putting log sine x. It makes no difference. So this I1 comes as I only. So now we'll go back to the step where we left the question and we assumed this integral I1. So that step was 2i is equals to I1 minus integral 0 to pi by 2 log 2 dx. So now I1 we got as I only minus integral 0 to pi by 2 log 2 dx. We'll integrate this, it will become x log 2 0 to pi by 2. So now after this step, this I will go to the other side. It will become 2i minus I is equals to minus. Now we'll put upper limit first. It will become pi by 2 log 2 minus lower limit is 0. So this whole thing will become 0. So it comes as I is equals to minus pi by 2 log 2. So here we can apply one more property of log to give this form. So this minus 1 will go in the power of 2. So it becomes pi by 2 log 2 to the power minus 1, which is pi by 2 log 1 by 2. So this is what we need to show. Thank you for watching my video. Keep watching my channel for such important questions. Thank you.